Okay guys, so now we are at part number 2, which is about superposition principle. And the superposition principle is applied when we are dealing with two or more than two sources in a network. Okay, now here I am using a word network. So remember that we were used to call these kind of things as circuits, right? When we have connected different resistors, we call it a circuit. Now I call it a network, so which is another way of calling the circuit. So we need to learn these kind of terminologies as well. Okay, so this is also called an electric network. In this electric network or in this circuit, we have two voltage sources and we have 5 resistors. Okay, since there are more than one voltage sources, we can apply the superposition principle on this circuit. Now, what is the superposition? What is the superposition theorem or the superposition principle? In order to understand that, I would pick one quantity. Let us say V1. Let us say that I want to find V1 in this circuit. Now, if I apply the superposition principle, then it says that first find V1 because of the 10 volt source only. Okay, first find the voltage V1 that happens due to the presence of 10 volt source only. Then find V1 again, that is due to the 5 volt source only. Okay, when I say 10 volt source only, I mean that there should not be the 5 volt source. The 5 volt source should not be connected. Okay, and when I say that find V1 using 5 volt source only, it means only the 5 volt source should be present in the network. All other sources should be removed. Okay, now think with me, please. When I say that I want to remove the 5 volt source, it means I actually want to remove the effect of this source. What is the effect of this source? The effect of this source is that, let me use the annotations so that I can draw here. Okay, what I mean by removing the effect of this source is that I want to make the potential between these 2 points 0. Why is that? Because right now, because of this source, the potential between these 2 points is what? It is 5 volts. Now, if I want to remove its effect, it is as if I want to make this effect 0 volt, right? And that is only possible if I remove it and I short circuit these 2 nodes. Okay, so whenever I am talking about removing a voltage source, I have to remove it and then short circuit the nodes like this. Okay, now if it was a current source, let us say that it was a current source like this. I will just draw a part of the network. Let us say instead of the voltage source, it was a current source. This is 330 ohms as shown here. Okay, so we have a current source. So what would we do? What is the effect of the current source? The effect of the current source is that it forces the current in this branch to be a particular value. For example, let's say that this was a current source of 2 amperes. Then because of the presence of this current source, the current in this branch will always be 2 amperes. It will not change, right? Now, when I say I want to remove it, I want to remove the effect of this source, it means I want to remove the 2 ampere current from this. I want to make the current 0. I don't want the effect of the source to appear in this circuit or in this branch. So how to do that? I would remove it and I will keep these 2 nodes open circuit. Okay, I would not connect these 2 nodes. So when I remove this current source, I will leave the circuit open circuit. This will ensure that there is no current that is flowing through this wire. It is as if there was no 2 ampere source here. Anyway, so you need to remember that when applying superposition principle, we have to find the desired quantity. I used V1 as an example, as the desired quantity. We have to find the desired quantity due to each source individually. Okay, so I will first find V1 due to 10 volt, then I will find V1 due to 5 volt and so on. Same thing applies for all other quantities. If I want to find V2, I would do the same. I would remove this source, I would deactivate this source, and I will find V2 because of 10 volt source. And I will do the same thing. I will repeat it by removing 10 volt source and then using 5 volt source and then find the value of V2 and so on. And the final answer of V1, for example, would be the V1 due to 10 volt plus the V1 due to 5 volt. Okay. So let me draw it here just quickly to clarify this concept. Okay, I don't have a space here. I will use this space here to, how do I notate? Okay, here it is. Okay, guys, so I would use this space. Let us make a very simple circuit. I will say that I have this kind of circuit where I have a 10 volt source and a 5 volt source. This is a 10 volt source and this is 5 volt. Let us call it voltage V1 and let us call this voltage V2. Okay, let's call this voltage source, this one VA, and this voltage source, let us call it VB. I'm just naming them for convenience. Now, when I want to find V1, I will have to deactivate one of the sources. Let us say I deactivate VB. So the only source that is present in my circuit would be VA. Now V1, due to the presence of VA, let us call it V1A. Let us say, just an example, let us say that it happens to be 2 volts. Okay, then the next step would be to deactivate VA and activate VB. Now, in the presence of VB only, I will have a certain value of V1. I will call it V1B. Let us say that that value is 3 volt. Just an example, okay? Now, what will be the actual value of V1 that is there due to V and VB together? And in the original circuit where V and VAB both are active, what is the value of V1? It will be simply V1A plus V1B. And according to these example values, it will be 5 volt. Okay, so this is how we find all of these voltages using superposition principle. So this was the idea. Now you have to draw this circuit. You have to design the circuit in multisim and then connect your ammeter and multimeter accordingly to find the values of all of these voltages and currents for both of these sources individually. Okay, let me go to the next page and let me show you. Let me first erase this, all of this. I will show you the tables where you will be recording all of these values. Okay, remember that we have 2 sources. Okay, so we will have 2 tables. One table will be for 10 volt source and the other table will be for 5 volt source. Let's move there to the next page. Okay, here we are. So table number 3 is for the simulation results of the voltages and currents when both sources are activated. Okay. Table number 4 is for the simulation results of all of the voltages and currents when only 10 volt source is active, which means you have to remove the 5 volt source. Similarly, table number 5 is for recording the values of voltages and currents when only 5 volt source is active. Okay. So here in the table, we are not writing the names V1, V2 or I1, I2, etc. We are simply using the resistors. Okay. So we are saying what is the voltage across 1 kilo ohm? Write the value here. What is the current that is flowing through 1 kilo ohm? Write the value here. Similarly for 220 ohms, 100 ohms, 1.5 kilo ohms and 330 ohms. Now it is straightforward to realize that the values in this table, in table number 3, should be the sum of the values of these 2 tables. Why? Because these are the results for 10 volt source only, and in this table you have the results for 5 volt source only. So according to the superposition principle, the sum of these 2 values should be equal to these values. Okay, because this is the table, remember, where you have both of the source are activated. Okay, so please remember this thing. Okay, now the later part is for the hardware experiment, so don't worry about it because we are not doing any hardware experiment. Now these are the questions, so you have to answer all of these questions. And as I said earlier, that if any question is related to hardware, then only you can leave it. Otherwise, you have to answer all of the questions, please. Okay. So for example, here, question number 2, compare the simulation and experimental results. So here you have to compare the results of multisim with the results of the hardware. So this means you cannot answer it. So that's why you can skip this question. Question number 3 is what? Superposition only applies to current and voltage, but not to power. This is a very important question, and I want all of you to think about it. And you can actually refer to your book also. You can actually refer to your textbook to answer this question, okay? But what we are desiring here with this question is a good understanding of superposition principle, okay? If you feel that you do not have a very good understanding of superposition principle, then please go and review the material from your book, please. And if you still do not understand, please let me know so that we can discuss it. Okay, guys, so with this, we end experiment number 3. And as I said earlier, and as we have seen, there are only 2 parts, part 1 and part 2. And we should be able to draw these circuits in multisim and perform all of these experiments. Okay, with this, we end this video. Thank you.